It's time for video lesson number 17. Today is solving equations. Last lesson was on equation vocabulary that we will be using, and now we're going to learn how to solve those equations. And this is video lesson number 17. For this video lesson, of course, you're going to need the notes you were given in class, TOC number 17, a pen or pencil to take notes. You may want to grab a highlighter marker or color pencil. You probably won't need it as much today because we're not talking about vocabulary, and this is part of our calculator section, so you can grab a calculator if you want it. All right, pick up TOC number 17. We are going to talk about why are we solving equations. What we already know an equation is when two expressions are set equal to one another and they all contain a variable, and so the big thing that you need to remember when you're solving equations is because it's two separate expressions on either side of that equal sign, there is a golden rule of algebra. And just like the golden rule that you have learned in elementary school that says treat others the way you want to be treated, it's the same kind of thing. So the golden rule, and you're going to need to write this down. Pause the video if you need to, because I'm not going to wait for a real long time, so you may want to pause it to write this all down. Whatever you do to one side of the equation, you must also do to the other side of the equation to keep both sides equal. So we talked about in class, and we showed you some visual models of solving equations, and when we did that, whatever we did to one side, we had to do to the other side to keep them the same. If you were to do something to one side and not do it to the other, then it unbalances the equation and it doesn't make it equal anymore. So again, the golden rule of algebra is whatever you do to one side of the equation, you must also do to the other to keep both sides equal. And I want you to circle that scale right there. That is what that's called, and that is just to remind you that you need to keep things equal and in balance. So go ahead and put a circle around that scale on the right. All right, so the goal of solving equations is to isolate the variable. And isolate is a fancy word for saying to get the letter or variable by itself to find out its value. So we're going to say this quite a bit. You just need to get the letter by itself, so you have just the letter equals a number. And that will tell you, it's basically naming what the value of that letter is, and it's figuring out the pieces of the puzzle. So again, our goal is solving equations is to isolate the variable, or in other words, get the variable by itself so we can find out what its value is. All right, so now we're going to talk about how do we solve equations. And it may seem more complicated than it is, but really in essence, and all we're doing to solve equations is to perform the inverse or opposite operation. So, and in order to do that, we have to talk about what does it mean to be an opposite operation. Okay, so let's start by saying we have four operations. We can add, we can subtract, we can multiply, or we can divide. And the inverse is simply the partner or the opposite operation, something we're going to do to undo it. We talked about properties already, and we talked about the inverse property of addition, and we talked about the inverse property of multiplication. The inverse property of addition involved a positive and a negative number. And a positive, we all know, is like adding. A negative is like subtracting. So the inverse of addition is actually subtraction. And so if the inverse of addition is subtraction, then we know the inverse of subtraction is addition. What I mean by this is that if I have an addition equation, I'm going to use subtraction to solve it. If I have a subtraction equation, I'm going to use addition to solve it, because that ties in with that inverse property of addition with the positive and the negative numbers. For the inverse of multiplication, if we go back to our inverse property of multiplication, it involved the reciprocal. And we know from using fractions and things like that, that a fraction is merely a division problem. And that line, that fraction bar, actually means division. So the inverse of multiplication is actually division, and the inverse of division is multiplication. So you need to know those partner operations, and that one operation is the inverse of the other. All right, here's the last little bit. I'm going to show you 4 examples of how to solve a one-step. These are called one-step equations because they have one operation. Once you get into 7th and 8th grade, you're going to see 2-step equations and then multiple-step equations, and then they get really complicated from there. But for our sakes, you're only going to be performing one step or undoing one operation to solve. So if you see something like x plus 12, the operation that's on the side with the variable is the operation that you're undoing. And since in this case I'm adding 12, in order to undo it, I'm going to subtract 12. That's the inverse operation. So let's go ahead and do that. And remember, the golden rule of algebra says whatever I do to one side, I have to do to the other side. So if you see I'm subtracting 12 on the side with the variable to undo the adding, and whatever I do to that side, I have to do the same thing to the second side to make it equal. So now I have to subtract 12 from 37 to keep that equation the same. Once I do that, 12 minus 12 is the inverse property, and it equals 0. So on that side, I'm left with just the x, which is what I want, and 37 minus 12 is 25. Now, once I have done that, I get my value. My answer says that x is 25. So the value of x is 25. That's my answer. That's what I would circle. However, with algebra, there is a nice little trick that allows you to never, ever, ever miss one if you do this correctly. It's called the check step. And if you see down below, I'm going to show you how to do it. What you do is you take the original problem, x plus 12 equals 37, and instead of putting x, I'm now going to replace it with what I got for the answer. It said x equals 25. So if I replace x with 25, and I put those little parentheses to show that I put 25 in where the x was, and then I add 25 plus 12, I get 37. If I get 37 on both sides, that means that I got the correct answer and my response is correct. The check step is not your answer. It's just a way of making sure that you got the correct answer and allows you to double check your work without having to worry about missing any problems. Okay, look at the example on subtraction. On this one, you see we've actually reversed the order of the equation. So instead of having the variable on the left, it's now on the right, and they will do that to you. It's okay. We're still going to solve it the exact same way. But just know, I always tell students to put their finger on the variable to know which side that they're going to do the inverse operation on. So if I put my finger on the x, my finger is actually going to be on the right side instead of the left. So then I know I have to get rid of the minus 4. The inverse of subtracting 4 is adding 4. So whatever I do to the right side, I also have to do to the left side. So now that I have added 4 to both sides, I end up with just x on the right, and 12 plus 4 gives me 16. So that is my answer, and now I'm going to double check it to make sure it's correct. Take 12 equals x minus 4, and instead of x, plug 16 back in, and now I can solve the right side. 16 minus 4 gives me 12. And since I got 12 on both sides of the equation, I know my answer is correct. Pause the video if you need to make sure you've written down all these steps. I want to make sure that you have everything because this is the expectation of the work that is required when you're solving equations. So make sure you have it all written down. Okay, the last two are the other partner operations. We have multiplication and division, and of course they're inverses of each other. So with multiplication, I have 6x. Remember we said that when you have a coefficient with a variable and they're right next to each other, that means multiply. They're not going to put a dot or anything in between them. They're just going to smush them together, and you have to understand that means that they're being multiplied. So once I do that, to do the inverse, I'm actually going to divide by 6. So I'm going to divide by 6 on both sides, and you can write this a couple different ways. You can write it with the division sign like I have here, or you can write a fraction bar and then write 6 underneath. We're going to show you both ways in class. If I have 6 and I divide it by 6, that's the inverse property, and I end up with 1x, which is the same as just x. And if I take 90 and divide it by 6, I end up with 15. So my answer is saying that x equals 15. I'm going to go ahead and check my answer by plugging it back in. If I have 6 and I multiply it times x, which I know now is 15, I should get 90. And if I take my calculator, this is a calculator section, so you can use it. 6 times 15 does indeed give me 90, and I know my answer is correct. For division, you can see on the right, we have x is divided by 12, but it's written as a fraction. And so what we're going to do is end up doing the opposite operation. That you have to recognize first that that's division, and then you have to multiply, and we're going to multiply by the number that's with the variable, which is 12. So we're going to multiply both sides by 12. I used the x here, should not have done that, but normally you would just use parentheses and write times 12 on the left, but I was just trying to be a little bit more clear for the video. Now, if I multiply 12 and then I divide by 12, again, I just end up with 12 over 12, which is 1. So I end up with x, and 7 times 12 is 84. So now that I've done that, I'm going to go back and plug 84 back into my equation to see if it works. If I have 84 and I divide it by 12, I should get 7. And if I plug that in my calculator, I do indeed get 7, which tells me my answer is correct. Again, pause the video, make sure you write down all of this work so that you can see how to solve equations and have this for future reference before your test. And now it's time to show what you know. Log in and take your homework quiz for TOC number 17. And if you can, please put a square in the right hand corner around TOC number 17 so that I know that you listened to the entire lesson.